Hi, I'm Jesse Spencer Smith, and I'm Chief Data Scientist for the Data Science Institute at Vanderbilt University. And today we're going to be talking about Git and GitHub. This is going to be an overview of Git and GitHub. We'll get into the technical details in later videos. But first, let's start and talk about what Git and GitHub are good for. So why would you even want to use them? Well, let's answer this by thinking about what you might need to do if you are developing software or collaborating with others or even just writing documents. One of the things you'll quickly run into is that you really do want to version your code and your writing. So you always want to be able to go back to something that you had before. You don't want to lose what you had before. And ideally, you'd like to be able to roll back changes without giving up everything that you've done before. So think about Google Docs and how you can do versioning with Google Docs. But when you go back to an earlier version with Google Docs, you lose everything that happened before. It'd be really nice to have the capability to simply roll back specific changes. Second, you want to be able to unwind these changes in a reasonable way. Choose where you want to go back to without giving up all of your previous work. You'd like to be able to track the changes and actually know why you made those changes. What was the intent of the change that you made? You know, it'd be a really good idea if you could share those changes with others as well in an efficient way. It's important to save your work in a safe place, not just have it sitting on your laptop, but have it available for others and kept safe. It would be it's important to be able to combine the changes that you've made with the changes that others have made. You'll want to track work that needs to be done as well. We do this with lists that we keep all over the place, but it'd be really nice to be able to tie very closely the work that needs to be done with the work that's already happened. And finally, it would be great to be able to estimate the work that remains to be done on a project. And let's go for one more. It would be really great to have a systematic way to test out any additions that you make to your code before you include it in the final version. So it turns out that Git and GitHub are designed to provide exactly these type of capabilities. As a matter of fact, it works like this. In these first few capabilities, these are provided by Git. The next few capabilities are provided by GitHub. So Git and GitHub are actually two different systems that work together very closely. This next project, this next portion right here, tracking work that needs to be done and estimating work that remains to be done on a project, this is actually GitHub projects. So this is another capability built on top of GitHub that's extremely useful. And finally, this is testing out additions before they're included in projects. This is capabilities of GitHub and also an approach to using those capabilities called GitHub Flow. So today we're going to be giving an overview of these first two portions. In later videos, we'll get more into the technical details, and we'll also talk more in depth about GitHub projects and GitHub Flow. So let's start with your local PC, with your local work. You have a workspace, and this workspace is likely to be a subdirectory where you are saving all the code that you're working on. So remember the different capabilities that we need. One thing that we need to be able to do is to version. So the way that you version code using Git is that you have a repository. A repository tracks all changes that you've made in your workspace. It doesn't do this by taking snapshots of what's happening. Instead, it records the individual changes that occur in your workspace. And it does so in what's called a directed acyclic graph. We'll talk about that a little bit later. But what's important to remember is that it's actually recording the diffs, the changes that you make to the files, and recording those within the repository. So you might not want to record everything that's happening in your workspace. Matter of fact, you might work on several files at a time, but only one file is really ready to be versioned. In that case, you want to be able to stage your changes. You don't want to have everything go into the repository, so it's actually a two-step process. The first step is to add the files that you want to have included in the repository, the differences in the files you want to included in the repository. You add them to a staging area. This is like an index. Then when you're ready to go ahead and make a commit, you're ready to go ahead and move all those changes into the repository, you give what's called a commit. And that gets you your versioning. It gives you a way to unwind your changes. But what about tracking changes and their intent? Well, the commit gives that to you as well, because when you make a commit, you can also leave a message that's tied to the commit that describes why you made those particular types of changes. So great. So now we have versioning, we have unwinding changes, we have tracking changes and their intent. So now what about saving work in a safe place? Something happens to this computer of yours, your work is lost. Well, that's where the remote repository comes in. And this is where GitHub comes in. Everything we've talked about up to this point is Git, and that's in the green. GitHub in the blue is actually a web-based service that provides additional functionality, but that is built on Git. And essentially, the most important part of GitHub is the capability of giving you a remote repository. So the remote repository is a mirror image of the repository that you have locally. Well, it's almost mirror. It's two different repositories that can talk to one another, as a matter of fact. So when you are ready to go ahead and move all of the changes that you've made, and you want to make a record of those changes at that remote repository, then you give what's called a push. And that actually compares the two. It allows the two repositories to talk. And so if the repositories are in sync except for those additional changes that you've made, you can successfully do a push and move those changes up to that remote repo. And that means that remote repo now has a copy of everything that you've been working on locally. Everything that was added and then committed and put into your repository. How about going the other direction? And the other direction is a pull. So let's say that someone else from another local repository has been making changes and contributing those to the remote repo. You can see what's been happening with a collaborator by doing a pull. So the pull pulls in all the changes that have happened. The two repositories are talking to each other. So you're not moving files. You're simply having the two repositories speak with one another, get in sync. Then a secondary thing happens. So the repositories get in sync. And then there's another sort of behind the scenes action where the local repository then instantiates all those changes and so updates your files appropriately so they reflect the work done by your collaborators. So how do you get this ball rolling? Actually, it turns out that often the easiest thing to do is to start with a remote repository. GitHub makes this easy. You can easily create a new repository. It's a good idea to start with a README file. We'll be talking about this in later videos. But you start with the remote repository and then you perform what's called a clone. And what the clone does is simply take the full copy of that repository, copies it local to a subdirectory of your choice, and then again, that behind the scenes action creates that workspace for you. Now you have everything that was up on the repo. This could be an existing repo of someone else's work that you want to contribute to. This could be a brand new repo that you simply just created because you want to begin the process of work on a project. But once you've done this clone, now you're off to the races and you're ready to begin your work. So let's see how well you did here. Can you pause the video for a moment and think about and label all of the parts here? So go ahead and take a moment, pause the video, and then we'll take a look back and see how you did. Did you pause the video? Well, if not, here are the answers. So repository, workspace, and the staging area are all local. They're in your PC. That's Git. In blue is that remote repository, and that's GitHub. And the actions and the order in which you take them usually is when you're working your repository, you're working in your workspace, you go ahead and add those changes, those changed files. When you're ready, you make a commit, that gets it into your repository. Then you're ready to move those things up to that remote repository. But here's the thing. First, you do a pull, because you want to make sure that your local repository and the remote repository has all the different changes that have happened remotely first. It will figure out how to move them in appropriately. So don't worry about overwriting or losing any of your changes. That won't happen. So you do a pull, then you do a push. That's a great way to make sure that the remote repositories and the local repositories stay in sync. In later videos, we'll talk about the specific technical aspects of carrying out this type of work. You'll see how to do this using RStudio or using another GUI. We'll talk about how to do this using command line. And then we'll talk about the other capabilities afforded by GitHub, such as combining changes with changes made with others, tracking work, estimating work, and testing out additions before they get included. See you in the next video.